Hello everyone. Today we are going to solve an integral problem. Here we have a problem that you can see tangent of x to the power of 5 dx. I prepared this problem for Hussein to solve. How are you, Hussein, today?
I'm good, thank you. How are you?
I'm good, thanks. So hopefully you don't hate this problem.
No,
It
that's
seems
okay.
scary, but I think, yeah, I think that's a good one to practice integration techniques
Yeah.
using trigonometric identities. Yeah, floor is yours. Please go
Okay.
ahead.
Okay. So I think I'm going to start by writing something on the side related to the derivative of the tangent. So
Sure.
if you remember that if you have a tangent of, if you have, delete this. If you have tangent of x and you want to take the derivative, so the derivative is secant squared of x, and I think secant squared, based on one of the trigonometric identities, secant squared is equal to 1 plus tangent squared of x, right? So I think I'm going to use this this property, this identity, in solving this problem. So,
and secant is the inverse of cosine of x.
right,
Secant of
yeah,
x is the inverse of cosine of x. Yeah.
right. So secant of x is 1 over cosine of x.
Thank you.
Okay, and so I think probably if I assume another variable like u, which here it is equal to tangent squared of x, then the derivative of u du is equal to 2 times tangent of x times the derivative of tangent of x, which we already have that. So it's 2 times tangent of x times 1 plus tangent squared of x dx. And okay, so this is a change of variables. So I'm going to apply this change of variable to our integrals. So the integral is integral of tangent of x to the power of 5 dx. So I'm going to rewrite that as tangent to the force times tangent of x times dx, and then I'm going to rewrite that equation again as tangent square of x to the power of 2 times tangent of x times dx.
Correct.
So as I have up here, u is equal tangent squared of x, and I have tangent squared of x down here. So I'm going to change the name. So I'm going to use u squared here, because this is u. And then, so I'm going to, because I don't have du, I'm going to multiply this by, so if I compare this with the du that I have up here, what I need to do, I need to multiply this by 2 times 1 plus tangent squared of x divided by the same thing, 1 plus tangent
Yeah.
squared of x.
Yeah, because you need to establish du.
Right. So what I have up here is du.
Correct.
So this is du.
Du.
Okay, so I have integral of u squared times du, and then on the denominator, so we define u as tangent square, and I have tangent square here, so this is u.
Yes.
So this is u, and so on the denominator, I have 2 times 1 plus u.
Yes.
Okay, so I can take this 1/2 out of the integral. So I have u squared divided by 1 plus u times du. And then, so here, I think what I'm going to do is subtract 1 and add 1 to the numerator. And by doing this, I can have, I think I can break it into 2 fractions. One is a u squared minus 1 divided by 1 plus u. And then the other one is 1 divided by 1 plus u.
Correct.
Times du. I hope I didn't confuse you here.
No, I can follow you.
Okay. And then let me add a page. So I'm going to rewrite that equation. So I have 1/2 integral of, so on the numerator, I can rewrite u squared minus 1 as u plus 1 times u minus 1.
Difference of squares, yeah?
Difference of a square, right. Divided by 1 plus u,
1
or u plus
plus
1.
u.
And then plus 1 divided by 1 plus u du. And then, so as you can see, the first fraction, we can cancel out u plus 1 from the numerator and denominator. So we have 1/2 of integral of u minus 1 plus 1 divided by 1 plus u times du. And I think,
and you cannot be -1, because for the second term we will have 0 in the denominator, and because of that we can cancel out 1 plus u in the first term.
Right.
Yeah.
Right. Yeah, that's a good point. You cannot be -1 because then the fraction is going to be undefined. And yeah, I think from here, the first term in integral is easy. Integral of u. So let me rewrite this in terms of like 3 integrals. So I have integral of, so I have 1/2 integral of u du minus 1/2 integral of du, and then plus 1/2 integral of du divided by 1 plus u.
Yeah.
So this is my first term, this is my second term, and this is my third term. And then, so the first integral is easy. So an integral of u du is 1/2 u squared divided by u, minus, in the second integral of du is u, so I have 1/2 times u, plus the third integral. So on the side, let me write this. If you have, I think ln of absolute value of u is equal to, if you take the derivative of this, it is equal to 1 divided by 1 plus u. Oh, I'm sorry. It is equal to 1 divided by u.
U, yeah.
Right? And then
Yes.
if I add a constant, so that constant is not going to do anything. So
Yeah.
so here in my case, I have, instead of u, I have 1 plus u. So that constant 1 is not going to do anything. So I'm going to use this this identity, derivative identity here. So so the third integral,
or you know, or a more involved approach or more comprehensive approach is to assume that, okay, 1 plus u is equal to t. You do another change of variable,
right?
but since it's very easy, you can just do it right away.
Yeah.
Yeah.
Okay. So I'm not gonna,
Yeah.
you know, do another change of variable.
Yeah.
Just to avoid
That's
confusion. Yeah.
absolutely correct.
Okay.
Yes.
But you're absolutely right. And then, so the third integral is 1/2 ln of absolute value of, I think it looks like a parenthesis, ln of absolute value of 1 plus u.
Correct.
Plus a constant c.
Yeah.
Now it's the time to, you know, replace or substitute u with the tangent squared that we assumed up here.
Yeah.
We did a change of variable. We assume u is equal tangent squared. Now it's the time to replace u with that. So I have 1/2 tangent squared of x divided by 2. The whole fraction is to the power of 2. Or
no,
sorry, not the whole
actually,
parenthesis, right?
not the whole one. Yeah, just, and also you need to correct the first term in the line above. Just,
yeah, just u is a square.
Yeah. Yes.
So I think I just multiplied 2 by 2. I'm going to rewrite that as 4, and then u squared is tangent squared tangent
Of x.
Yes, tangent square of x to the power of 2 minus u is tangent squared of x divided by 2 plus 1/2 ln of 1 plus tangent squared of x plus c. And then from here, we can simplify further. So we're done here. I'm just, you know, simplifying it more.
You want to simplify further, yeah.
So tangent squared to the power of 2 is tangent to the power of 4 of x divided by 4 minus tangent squared of x divided by 2 plus, I think 1 plus tangent square is, we can change it to secant square.
Not squared. Could you please check the top of the, you know, problem? Is that the squared?
I think that's the squared, right?
Yeah, okay.
Yeah, because yeah,
that's 1 over
because
cosine
secant
of
is 1 over cosine. Yeah.
Yeah, okay. Yeah. Just to make sure. Thank you.
Yeah. And then I think here I have 1/2 ln of absolute value of secant squared of x plus c.
Yeah.
And then just bear with me one more line. So tangent to the force divided by 4 minus tangent squared of x divided by 2 plus, so based on the property of ln, which says the natural logarithm has a property saying that if you have ln of x to the n, you can write it as n ln of x. So I'm going to use this identity. So I'm going to write that as like 1/2 times 2 ln of absolute value of secant of x
Secant of
plus
x.
c.
Yeah.
And then this 2 and 2 cancels out, and I have tangent to the force divided by 4 minus tangent square divided by 2 plus ln of absolute value of secant of x plus c. I think that's the answer.
Yes, yeah. And the reason you put absolute value for secant is that the ln of x cannot be a negative value for ln, for the
Right,
function of ln of x.
right. ln
And
is
since
undefined for
secant,
negative values.
and
Right,
since secant or trigonometric functions are cyclic, they can be either negative or positive. So to make sure it's always positive, you put absolute value around
right.
it,
That's correct.
absolute sign around it. Yeah.
Mhm.
So yeah, great. Thank you, Wilson, very much. Please scroll up to just summarize what you did. Yeah, you used those trigonometric identities. Secant squared is equal to 1 plus tangent squared of x, and then you use change of variables technique, and then you started solving the integration problem. You used u, and then you proceeded, and knowing that u is equal to tangent squared of x, it's always positive, so it cannot be, for example, -1. That's why you canceled out in the following page u minus 1 plus times u plus 1. So that's why you did that, correct? And then you just followed simple techniques for integrals, and yeah, you solved the problem. Thank you very much.
All right.
Yeah, for viewers, if you like the video, if you learned something, yeah, please subscribe to our channel and hit the notification bell. Hopefully you will learn more from our channel in future. And until the next video, take care. Thank you. Thank you, Hussein.
Thank you. Bye, everyone.